Hey everyone, I just wanted to show you the latest upgrades I've done to my Predator build. Uh, this is a Wii mote setup with Raspberry Pi. This is the Pimeroni on off shim. That's just a spacer. It's like that. And that is a PCA 9685 servo bonnet from Adafruit. Those are some leg spacers I just had laying around. It just adds a lot of stability, and I'm gonna have to get some more parts so I can mount this underneath there, protect everything, because the SD card, which is the heart and soul, is right there. As you notice, there's nothing really keeping it in, so I'll just do a metal block. I actually lost two SD cards a while back, and who knows where they're at. Okay, the nice thing, Pimeroni on off shim. Have to have one wire turned off in the Raspberry Pi for it to work. Okay, on it goes. Nice little boot screen. Now I keep all the passwords and everything standard here, that way no one could know it. And there's a nice little boot up sequence, nice typical Linux boot. Now I have it set to boot to console. You could have it boot to the graphics user interface, but that usually adds a lot of overhead. The key on this is once it comes up, come on, when it decides to, come on. Okay, set to automatic login. Not necessarily a recommended best practice. Okay, we're going to run this as root. Boom. And then we're going to do this. Okay, so it doesn't have enough time. So you got to do this red button on the back here. It's going to flash while it's doing its thing. Come on. Okay, and the way I've got this set is real simple. I've got it set to display the button stat. That's okay. Report mode, LED, rumble, battery, extension type, error status, buttons. Okay, accelerometer, nunchuck, stick, ACC, which it shows there, and then buttons. First buttons is buttons on this. Second set of buttons is for the nunchuck here. Okay, and now the way that I've got this set is I've got it set to, basically a GPO IO type button press for, debounce. And I built that into the script, so the whole script itself is fairly modular thanks to Matt Hawkins. So we're going to okay, travels up. And notice I'm fairly happy with this setup. This is a lot better than the 6 second delay I had with the Arduino setup. The main issue with it is that it's only a 10 megahertz processor. Well, this is a 1.7 gigahertz Cortex ARM much faster, much more capable, and a lot more capable. So this is I believe this was a 32 or 35 kilogram centimeter servo. That's about 1 to 2 foot-pounds of torque, and it's a 1-to-1 gearing ratio. This is a high-tech HS785 HB winch boat servo. This is the mod updated 788, and the way that I've got it set, okay, and this is why you have running script. That is the stick. So, and now I've got the actual converted values. So now I'm going to hit plus and minus, which will kill the script. Okay. Now we're going to go in and we are going to view okay. Standard Python script. Okay. I got this, added this GNL GPU licensing, just not to be used for commercial credit, gain or profit, unless credit given to authors. There's a CWID library that I compiled from source. There's time, OS, board, SEL, SCDA, SIO. There's Adafruit PCA 9685 board. Those are the settings specific to the board. This is for servo controls. And there's 2 different modes that I'm running this board with. For pulse width modulation for the LEDs, and then the servos themselves. Basically, you call it up, kit.servo, brackets number, which is channel number 0 through 15 for a total of 16. Dot angle equals and then a value from 0 to 180. Now I've got this set to this is servo 0, this is servo 1, 2, 3, and then this is what I call the default position. This is where it's stowed away for carrying whatnot. So 160, 20, 180, 180. This will move more than 180 degrees, so I had to step back things a little bit, and I had to do a custom build on this because there really isn't a bracket on the market that does this. I literally had to basically fab this slot in. This keeps this in place. You got this clamp here, this clamp here, and then this is driving the whole thing. Same here, clamp here, all good. And now we're going to go down. Okay, those are the button counters. Yeah, I set those as 0. Now here's where the guts of the script really start. These are the file calls. I need to get some speakers. I'll do another video once I actually get some sound, because this is what I like to call a prototype, because I'll have 2 sets of these. I was always taught you have 2 sets of whatever. That way something breaks, you can rob parts from one, get the parts on order, and then it's a minimal downtime instead of waiting days, weeks, months, whatever, depending on what you're trying to do. So I can prototype this. This is a lot more mobile than this old setup. which those are ostrich skin leather. I'll be using those for basically a Malong type skirt. So this is the old setup, fairly heavy. I'm hoping to shed some weight because this is the new setup, and this is an interim setup. I'm going to have to rebuild that pack from scratch so that I can fit a linear actuator down into here, and then just have like this bracket sticking up, and then all you're going to see is this. And then instead of this little PVC pipe, I'll figure out a way to just fit a linear actuator, but I'll have to program in a RoboClaw controller, which has all sorts of support with everything and is primarily used in a lot of the robots type stuff. Now let's get into some of the stuff. Okay, you saw that stream of stuff. This pulls the battery status. This pulls the buttons state. This pulls the ACC from the first ACC. And then the nunchuck is its own self-contained sub-dictionary. Now you can't, there's a specific way you have to pull it. So to pull the buttons from it, you have to, pull the buttons from the function called nunbutt. So there's nunchuck button, nunbutt, and then ACC, NACC from nunbutt, and then, nun end stick from nunbutt stick, and boom, and then this is a remap calculation, which it's new value minus old, or value minus old minimum divided by the subtraction of the old. Let's pull up my notes so I can actually tell you correctly, which you always want to document everything in your robotics classes and whatnot. So it's okay. It's new value equals old value minus old minimum, that math, divided by the old maximum minus the old minimum, then those calculated, and the multiplied times the new max minus the new minimum plus the new minimum. Now, since the new range is 0 to 180, the whole calculation is times 180, whatever. And depending on what your values are, that's going to determine what you have to calculate it as. And you run that stream, so if it conks out, it will show the last reading before it conked out when it went out of range, and boom, you're good to go. Now this is where I was playing with some stuff, and X, Y, and there's, okay, now what this does is if you hit plus and minus, equals 0, means pressed or true, it's going to rumble 1, let you know that got pressed. It's going to set it to this neutral position, and I give things time to run. And then I also got it set, the battery reading. If it's less than 79, I've noticed if it drops below 70, it stops communicating. So it's going to rumble and move to neutral, and it's going to let you know, hey, and it won't stop rumbling until you shut it off. And these are the if sequences. The way I got it set is you got, if buttons and CWID button right, right pressed, and then I got button right count equals button right count plus 1. Print, button, right count, comma space presses so far, and then if button right count equals 3, play that. Because I got it set to use A play, because you can do MP3s and waves and AUGs and all that, and I kind of need a speaker so I can sort out some of the sound issues. And this is the home section, because the way I got it set is until the value hits 4, it's going to be in this neutral position. And then once that, 0, so this is at max travel basically, and then once you get it to 4, it goes up to here, and then this goes up, and then all the cannon actions go on with this servo and this servo. I had tried to do it to where it was, this angle equals this angle equals end stick X, but because of the way that things are, that won't work. And it's just a bit of an issue. And, very modular. You can add this as many iterations. This is what's called a while true loop. They're in Python. It's a very simple type setup, and it will run in infinitely the loop until you kill it, which is why we have the plus and minus to kill it, because if you run this as a service, which I'll cover that at a later point, how to set it up as a service. There's a few different ways to do it, and the old school way is still probably the easiest and most popular way to do it. There's a new way to do it that, Linux, changed the way that they, do services and whatnot, and it's various, kinds of painful, but it is what it is. The Linux community is, very aggressive and updating their stuff, and with an eye towards security and whatnot, because most of the world's web servers are run on Linux. This Raspberry Pi will, run a web server. It can function as a firewall. There's infinite functionality with this. The only thing it can't do well is video LAN player, because it doesn't have enough oomph to really handle all of the decoding and encoding required for video playback. That it is what it is, so big whoop. And now here's the nice thing. We're going to tell it to shut down, so we're gonna hit this button. Watch what happens next. Broadcast from, it's shutting down, so boom. And there you go. Have a good day, everyone. Hope you enjoyed the video.